Hello, hello. Oh my, you're way too excited today. Um,
I love matrices. Whoop, whoop. Okay,
we
I'm
will
done.
talk after we do this lesson. If you remember, if you did the last lesson with us, solving three equations in three unknowns is super fun and lots of paper and took a lot of work. I mean, it's doable, but it's kind of a pain in the neck.
The
So,
tush.
yeah, it was a lot of work. It took a lot of
The tushy.
pain in the dupa, as Grandma would say.
My
Um,
grandma doesn't say that. My grandma would have said a naughty word.
Whatever. Yeah, your grandma also likes to party, so that. Wait, no, that was cat. That's a different class.
My grandmother does not like to, I mean, she probably at one point liked to party, but she's past that.
Let's find a better way to have this conversation. So, all right. So we've done problems like this a couple sections ago. We had two equations and two unknowns, and I'm going to kind of just walk you through it with the slides versus me struggling to write the whole time.
Before this year is over, he's gonna go a whole video without that noise.
Yeah, no, it ain't happening. So what we would do, what we did back in like 6-1, we would multiply the first equation by -2 and add it to the second. And look, hey, the x's went away and the y equals 1, right? And so that system, I could rewrite it as the first equation, 2x minus 2x plus, x plus 2y equals 7 and y equals 1. And then to find x, I would have to plug 1 in for y in the first equation, right? So we're going to look at a slightly different way of doing it with matrices, okay? So this is what it would look like if we didn't really have to worry about all this, because those x's are just kind of like, x and y's are like places.
Wait, can we talk about what a matrix is really quick?
Sure, if you want.
I mean, I don't know if they've ever seen a matrix. I mean, surely they've seen a matrix.
Possibly.
So a matrix is a rectangular array of numbers. You see it often in programming and computer software to organize large sets of information. For us, we're going to use it to help us solve a system. And if you think this is like the coolest thing ever, in college, you can take a class called linear systems or linear algebra, and it is all kinds of matrix all the time.
And this is like, I mean, like imagine the y's, like I imagine them being in there, right? It's just a way, what we're doing, when she multiplied by 2, we took all those coefficients, the 1, the 2, and the 7 in the first equation and multiplied by -2, and that's where we got this negative, when she did this step down here, that's where we got the -2, the -4, and the -14. You don't even really think about that. But the x's and y's are kind of like placeholders, is kind of how I think about it. So if we just keep them organized, x, y, and constant, then we don't really kind of even have to write it. Is that kind of cool with you?
I mean, I like to write less.
I like to write less too, okay? So I mean, I know they're, like I can imagine them being there. They're not really there, but I could, because all I'm really doing is fiddling with the coefficients. Yeah, that's my new puppy making my old puppy unhappy. So, all right, so what we did, the first thing we did was multiply the first equation by 2. So we're going to take all these numbers, the 1, the 2, and the 5, and multiply them by 2. So we multiply that row by 2 and add it to the second, we get the first row, and then the second row becomes 0, 1, 1. And maybe I should have kind of stepped in between or something, but this.
Yeah, what just happened is we said, okay, let's imagine we're multiplying this row by -2. And it becomes -2, -4, and -14, right? And then let's imagine we combine these. And when we combine them, we're actually going to change this bottom row. So -2 plus 2, that's 0. -4 plus 5, that's 1. -14 plus 5, -14 plus 15, that's 1. Now notice here that our top row is unchanged, like we never did that.
Yep.
And our bottom row is the culmination of us combining the new top and bottom rows.
Okay. So that, and what we're doing is because all that's really happening is we're manipulating the coefficients of the equations by multiplication or addition or subtraction, right? And so we're just keeping track of the coefficients and using the columns to track x, y, and the numbers. Okay.
So if you're wondering, so, if you're wondering, like, why did this one not stay changed? Like, why didn't it stay like this? It could have.
It could have been.
Um, it could have stayed like this, but we tend to go back to the original. That's just like, we just tend to do that just in case maybe there was an arithmetic mistake or a sign mistake. We just go back to what was given to us so that we can make sure that there are no mistakes.
And the fact that x plus 2y equals 7 is an easier equation to work with than negative 2x minus 4y equals negative 14.
Right.
So I chose the easier equation, So at some point, and when we're doing systems equations, once we have y or whatever, whenever we have one of the variables solved, what do? We have to go back to the original equation or go back to one of the previous equations to solve for the other variable. I'm sorry, my brains are all being a little annoying right now. I thought walking them before video would have settled this, but no, I guess not. So, okay. So now, let me try to do it without making that awful sound. So what we're going to do is set up the matrix equation equivalent of this. So let's figure out, we need to ask ourselves a couple questions. Are the variables aligned vertically? Are the x's, the y's, and the z's in order? And in this case, it looks like to me they are. Okay. So I'm just going to make it into matrix form. Okay, and Miss Young is going to write this down for me because when we go to the calculator, I'm not going to remember this. 2, 1, and 4, and then we're going to write 4, 1, and 2.
And while he's writing this, think about our last lesson and how many steps it took us to get to the answer of this 3 variable system.
We've already done this. This is the exact problem from the previous lesson. Sorry.
Yeah. So what he's doing right now is he's stacking all the x's on top of each other, all the y's on top of each other, and all the z's. This is kind of an important thing to note because if these are out of order, you do have to fix it so that the x's are in one column, the y's are in one column, and the z's are in one column. And then sometimes you'll see a line, like you'll see, if you ever see a textbook with this, you might see a line here. Sometimes you won't, sometimes you will. And then this should be your constant, your number without your variables on it.
So the cool thing, and the reason we're showing you this, is because once we have the matrix, the calculator has a function that does all of the
Now,
arithmetic.
before you flip over to the calculator, let's anticipate what we want the answer to look like. We want to know, what does x equal, what does y equal, and what does z equal? Which means we need one of these columns to have one of these rows to have a 1 in the x and a 0 in everything else. One to have a 1 in the y, so we can say 1y, but no x's or z's. And one of them to have a 1 with the z and no x's or y's. So we need, and this is called the identity matrix. That's what it's called. It took me a second to pull that back from my memory. So if we have a 1, 1, 1, right down that main diagonal, that's called the identity, okay? And you probably did learn that at some point, hopefully in Algebra 2. And so what that's telling me now is my 1x is going to be equal to whatever this number is. And I have 0 y's and 0 z's. Then right here I have 0 x's, I have 1 y and no z's, and that's going to be equal to whatever the number is right here. And then I have 0 x's, 0 y's, and 1 z, and that's going to be equal to whatever I have right here. So what I'm looking for is this sort of identity situation where I've got 1s along the main diagonal and 0s everywhere else.
I could have gone backwards and, like in the previous example, got rid of the y's in the first row and had this, but and even sometimes I could have had numbers here and here and worked my way back up from Z.
Yeah.
Okay.
Actually, if you back up, will you back up to the previous slide? This is not in our script, but I feel like maybe it's worth a conversation here. If we were to look at this point in this matrix, right, we would really want this to be 0. That's what we would want.
Yeah.
And so I had 1x plus 0 y's is equal to 7, meaning x is equal to 7. Right now, you can see right here, I'm actually not to the point where that's possible. So if I wanted to combine these, this would have to become -1. So this would have to be divided. I'm not going to do that for you, but I want you to understand kind of like the thought process here behind what's happening. Now, the nice thing about new technology is when I was in high school, we had to do all this by hand. Probably Mr. Bobby too, or maybe they didn't even do matrices when he was in high school. But now we have the magical calculator. So let's hop over the calculator and let it do the work for us.
All right, so we're going to switch over to the Inspire and we'll make a new document. Okay. And I'm going to add a calculator. And I'm not going to do this for you forever, but since this is the first time doing it, we're going to run through a couple of these together. The button immediately to the right of the button, which I have deemed the math button in before, we're going to use these functionalities. And we've been here before for like logarithms, I think, and we've done absolute values or whatever. But if you go down here, there are things that look like matrices. Now there's the 2 by 2. The problem is like we want 3 rows and 4 columns, right? That's how many we had. We had 3 going across.
Yeah, we have 3 across, 4 up and down.
Okay, so you need to know this if you're using the calculator. This guy, the first one will give you what it says. It gives you 2 across and 2 down. This one will give you, this one will give you 1 row across, 2 down. This one will do that. But this guy doesn't do what you think it does. This doesn't make a 3 by 3. When you click it, it lets you pick and customize how many you want, except I don't want to do that. So when I pick that one, now rows go sideways or go across like this. Yeah. And
rows lay down.
Columns go up and down.
Columns stand up, right? Think about like the column on a building.
And it's just like in spreadsheets, if you use Microsoft Excel or numbers or something. So we had 3 across and 4 down. So I need to up my number of columns to 4 and hit OK. Now I have a blank template, and this is where Miss Young's going to help me out with the numbers.
Okay, that's a 2.
That was a 2.
And then what direction are you going?
And then next, right up top across the top row.
Okay, 2, and I mean a 4.
Okay.
And then a 3.
Okay, and I'm hitting tab, by the way, to go to the next one.
Then a -2.
And then tab takes you down to the next row.
And then 1, 1, 1.
1, 1, 1. I should have remembered that.
And then 2.
And 2. All right. This is,
and then 4, 2, 5.
And
then 22.
22. Was that -22 or 22?
I just wrote 22, so I hope it's 22.
Let's see. You were right. I should never doubt you. I should never doubt.
I'm wrong too sometimes.
Okay. No, I'm the one that's always making my first
So
mistake.
he just hit enter, and it gave him his matrix back.
Okay. Which is fine because I entered that. I just wanted you to see how to enter a matrix. Now we can do, like in the coming sections, we're going to do more with this, but what we're going to do is perform a command on it. So if I want to do a command on the calculator, everything lives in either one or two places. It lives here, or it lives under the menu. So let's press menu and just explore, okay? And I'm thinking I want to probably go to 7 because we are doing something with these things called matrices. So I'll go down to 7. Like, I'm not like taking out a big, risk here. All right, now, what is I've never done this before. I've never seen this before. What is that diagonal thing that Miss Young was talking about? That's what we call row reduced echelon form. And it's basically going to do combinations of adding rows, combinations of multiplying and adding rows for us until it gets to the answer. Okay?
Right.
And so when you do
the same thing as elimination. When you do elimination method with the X's and Y's in the problem, you're actually doing reduced row. It's just you don't have it in matrix form. You have it in algebra form. So it's actually the same exact math that you already know. It's just if you don't want to write the letters, you don't have to in a matrix.
Now I got to type that matrix all over again, right? So let me get in. No.
And you can actually type RREF open parentheses and it will work as well now that you've seen this.
Okay, so I could literally type RREF using the letters, if you don't remember what that was, and then open parentheses and then go to tell. Okay, so if I hit enter now, wow, we get x equals 3, because that's an x. We get y equals -5, and z equals 4.
Which is pretty magical when you think about how long it took us to solve this problem in the last lesson and how many steps that took. This is pretty powerful and it will make your life a lot easier. Now, you might run into a problem that says solve without using matrices. And then you can only use matrices to check your work.
Well, there's ways of making you do the problem. I can make you do it if I really want. All right. So, oh my gosh, this is driving me nuts today. Okay. I'm trying to put the picture right where you. Oh my goodness, I put the picture exactly where you had it. So, all right. Anyway, I'm so excited for myself. All right. So we're gonna do this. I'm not gonna go back in the show mode so I can see the numbers. But we have a couple here, and I probably should have jumbled up the letters. I didn't do that. I'm silly. So just like when we're solving equations using algebra, there are two weird things that can happen. We can get no solutions or infinite solutions, and they look, we get 0 equals 0 or 5 equals 5 when there's infinite solutions, or what we call a dependent system. And if we get like 7 equals 13 or 0 equals -5, that means there's no solution, okay? And that same thing will happen with the RREF. So let me help Miss Young from having to spit out numbers. So,
oh, well, I was writing them.
I can just do.
Oh, well, stop.
Yeah, I'm sorry. I was just trying to make life a little easier for you. And
so he just typed RREF. He did not go to the menu that time. So just that is normally what we would do, just because it takes less time than going through the menus.
I mean, that's a judgment call. You can go to the menu, you can just type it. And I did have to do an open parenthesis. Then I can go back to my matrix command under the math menu. And it does, oh, it didn't preserve. I thought it was preserve the last size I made, but all right, whatever. And so I'm just typing the numbers, 1, -3, 1, and then 2, -1, -2, and 2. And let's see, 1. And again, I'm placing the 1 in there because it's not, even though we don't write the coefficient, we as mathematicians know there has to be 1 there. Okay, do I have it? They're all correct. The nice thing is, like, if I made a typo, I would just go back into history and fix it, but I think I have every number right.
It looks good to me.
And how is this one like the other one, but different? And what does the matrix at this end tell me? But if you look at this last equation, there's not 0, 0, 0, and then a 1. What does that tell me? It'd be 0x plus 0y plus 0z equals 1. Well, all of them zeros make 0, so 0 equals 1. That one, this one on the left side, has no solution.
Yeah, it says 0 equals 1. That's what that last one says. And you also know there's something wonky here, because reduced row echelon form should take you all the way down to where these are zeros and these have a number in them. I mean, the answer could be 0, of course, but and just in general, that doesn't happen very often. So, but this last one, this is the false one, right? And we have to know that this is the false one. We have to know that this says 0 equals 1, and that can't happen.
But we would say that that system has no solutions, or is, yeah, so, okay. And then if I move over to the other one, I'm going to do RREF again. Or did you just erase everything?
Yep.
Okay. And open parentheses, grab matrix again. Make this into a 4, and then type in numbers. -1, 6, 2.
You should get excited when you see a system because like, you can get the right answer, because even if we ask you to do it algebraically, you can throw it in a matrix and find out what the correct answer is with little to no work. And we might not take it for the work, but you'll know if your answer is correct.
Yeah, well, and if you do all, yeah, you check it in the calculator and then go back and do all the work, you definitely know you're making it easier on me because then I can grade it to be right. So, all right, what does this one tell me at the very last line? Again, I'm getting some extra weirdness because I'm expecting those ones along the diagonal, and I ain't got it, but I get 0 equals 0. And that tells me that this has infinite solutions where they're overlapping and there's not a unique solution. Okay, so there's always two weird cases with solving systems. They're either the no solutions or the infinite solutions. And inevitably, it's going to come down to 0 equals 0 for an infinite and 0 equals a different number for no solution.
In a matrix. And other things, like anytime that at the end the variables are all gone, you get a false statement, no solution, you get a true statement, infinite solutions.
So that's it. That's all she wrote. It's a lot easier than doing it by hand. There's your practice problems. And I will hope you have a wonderful afternoon or morning or whatever time it is.